Today we're working on module 2.2 and 2.3. They both were kind of small, so I lumped them together. So here we have a polygon whose vertices are given. Let's do it this way. So 2, -2, -5, 2, -5, 7, and 2, 3. There's my polygon. And now I want to know, is it a triangle? Well, obviously not. Is it a rectangle? Obviously not. Is it a parallelogram? It kind of looks like it. How can we guarantee that it is a parallelogram? The lines need to be parallel. And obviously, this side is parallel to that side. Those are the wrong marks. So there and there. Okay. Now we just need to check to see that the other side is parallel. How do we figure that out? We could do side lengths. So this is 1, 2, 3, 4, 5. And this is 1, 2, 3, 4, 5. Does that guarantee that that the other set is parallel? If I have one set that's equal and parallel, actually that is enough in this case. But there are some cases where that might be a little bit ambiguous. Let's check the slope. So the slope of this side is down 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7. So -4 over 7. And then 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So yes, they are. Both sets are parallel, so this is a parallelogram. All right, so what needs to happen in order for a quadrilateral to be a parallelogram? In the first one, opposite sides are equal. If the top is equal to the bottom and the left is equal to the right, does that guarantee that it's a parallelogram? It does. That is enough. So what about the second one? So if I had a parallelogram, the diagonals are not going to be the same length, right? However, where the diagonals meet, we'll cut each diagonal in half. So the short diagonal has two segments that are the same length, and the long diagonal has two segments that are the same length. So what do you think about figure 2? Is that a parallelogram? So this side equals that side, or that segment, and this segment equals that segment? No. Yeah. So if I had, like if these were short and these were long, does that make a parallelogram? No. Nope. The diagonals have to be cut in half in order for it to be a parallelogram. Okay. Another thing about parallelograms is opposite angles are equal. So this angle is equal to that angle, and this angle is equal to that angle. So here we have one set of parallel sides, so we know that those are parallel. Okay. And then we know that this angle is equal to this angle. Yeah. So if I have a set of parallel lines cut by a transversal, this angle will always equal that angle. Those are alternate interior angles. Okay. So this angle has to be equal to that angle. And then we have this little one equal to the little one, which means that the other side has to be equal to the other side. So it turns out that this is a parallelogram. Okay. What about the next one? This one's a little bit tricky. So let's look at this triangle. Is that triangle congruent to that triangle? Look carefully at the angles. This angle equals this angle, and that angle equals that angle. So are the two triangles congruent? No, we don't have anything that matches, right? So one of them would need to be flipped. If this was a single and that was a double, then it would work. The other one that you're going to run into looks like this: parallel, parallel, equal, equal. Would that be a parallelogram? So can you think of a non-parallelogram that has one set of parallel sides and one set of equal sides? Well, what about a trapezoid? Right? So if the top and bottom are parallel and these two sides are equal, does that guarantee that that second set of sides is congruent? No. So that would not be a parallelogram. Okay. Here we have two sides of a parallelogram, and we need to find the point that would create the other two sides. So it needs to be somewhere in there. How would we find that? So we could try flipping that. So -3, 4, if we flipped it to 3, -4. So 1, 2, 3, 1, 2, 3, 4. Doesn't quite look like it. Right? That's not quite a parallelogram. Okay, that didn't work. What else could we try? You could guess. How can we guarantee to find the correct point? Well, what do I know about that new point? It has to have specific qualities. Wherever it is, so let's say it's right there, wherever it is, this line here has to have the same slope and the same length as the top line. Right? So what is the slope of this top line? Up how many? So how far is it from here to here? 2. We're looking at the y values. From y equals 4 to y equals 6. So we're going to go up 2. Okay. How far is it from here to here? 5. From -3 on the x-axis up to 2 on the y-axis. So we're going to go right 5. So from here I go up 1, 2, and I go right 1, 2, 3, 4, 5. So that point would be -3, 0. And there's my parallelogram. We could have used the other side. We could have said, how far is it from -5 to 4? I guess we want to go the other way, from 4 to negative 5. That's a drop of 9, right? So from here to here is negative 9. How far is it from here to here? From negative 3 on the x to negative 5 on the x would be 2. So we're going to go left 1, 2, and down 1, 2, 3, 4, 5, 6, 7, 8, 9. So from 6 down 9 would be negative 3 on the y. From 2 over would be 0, negative 3. And there is my parallelogram. So it doesn't matter which side you use, they'll both work. I don't think so. So that is the easy way, in my opinion. There's a much harder way to do it. Okay. So in a parallelogram, we know that each diagonal gets cut in half. So we have those equalities. And then as far as angles go, this angle will always match this angle. And this angle will always match this angle. And that's true for every corner. Okay. Now, they've kind of tricked us a little bit. They drew this angle and labeled it as 31, and they drew this angle and they labeled it as 54. So that does not mean that those two angles are equal, which, in my opinion, they shouldn't have drawn the lines, but they did. So how am I going to calculate the size of x? How do those two lengths measure up to each other? They have to be equal because the long diagonal and the short diagonal both get cut in half when you draw both diagonals. So I know that 3x minus 3 is equal to 9. So I just solve. Divide by 3. X is equal to 4. Okay? All right. So I need to find ZWV. So ZWV. How big is that angle? 31. Yep. That angle and this angle are equal. So this is 31. Okay. What about ZVW? So what about this one? That one's going to be 54 because it matches up with this one. What if it wanted that angle? You would add those two together and subtract from 180. Yep. Okay, this is a little bit tricky. Here we have an isosceles triangle. And we know at some points, we know that this point is negative p comma 0. So how big is this length right here? It's length p. Okay. And then this point right here is 0 comma q. So this length is q. So what is the coordinate of this point? Well, how far to the right will it be? P, the same distance as the one on the left. So this is P, and how far up is it? Now Q is from here to here, so 0. So this would be P comma 0. Okay, let's look at a different example. All right, I need to label this. The distance from here to here is J, and the distance from here to here is K. So what would the coordinate of F be? So this is going to be J, so J comma 0. What about that one? How far right and left is it? 0. So this point is 0. How far down is it? K, but we need to put it as negative K. So negative K. All right, let's look at another one. All right. Let's not do this one. We already did one of these. Okay. So this distance is Q, and this distance is P. Hey, I bought that for you. You hurt my feelings. I don't remember what I wrote on there. So, what is this point? Not 0. It's P units to the right and Q units down. So it would be P comma negative Q. Okay, that's the easy one. What about this point? How far to the right is it? What? Close. 2 copies of P, right? P is on the x-axis. So 2 copies of P will get us to the x value, so 2P. And then what is the y value? How high is it? 0. All right, there's one more type that I want to see if we can find. Nope. Nope. Maybe this one doesn't have it. Oh, okay. All right, that's it. Get to work.